Hello, I'm Laura Foote, and today we're going to be looking at space and shape. This is part 1 of 3 parts, and today we're going to be looking at 2D shapes. The key concepts we're going to be looking at today are measurements, including the lengths that we need to deal with, and conversion of these lengths. And that would be in metric and imperial units. We're also going to be looking at area and perimeter. Now let's have a look at some of the terminology that we're going to be needing. Measurements and conversions that you need to know, in other words, you need to learn these, are, and let's highlight these so that we know exactly what we need to know, is 1 centimeter is equal to 10 millimeters. 1 meter is equal to 100 centimeters or 1,000 millimeters. 1 kilometer is equal to 1,000 meters. 100,000 centimeters or 1,000,000 millimeters. And these are just things that you need to actually learn off by heart because they will not be given to you in the exams. The harder ones we need to learn because these are in 2 dimensions, and that means that they are square units, which means that you are actually looking in 2 dimensions. And for example, 1 centimeter squared, and sometimes it's better to draw pictures for yourself, it's actually 1 centimeter by 1 centimeter. And if I had to convert that to millimeters, 1 centimeter would be 10 millimeters by 10 millimeters. And 10 times 10 is 100 millimeters squared. So therefore you can see that 1 centimeter squared is 100 millimeters squared and not 10 millimeters squared as most of you think. Right, similarly, 1 meter squared, which I would have calculated by saying 1 meter times by 1 meter. And I could obviously use the same diagrams, and 1 meter is equal to 100 centimeters by 100 centimeters, and 100 times 100 is 10,000 centimeters squared. Don't forget to put the little 2 because that is showing us that they are square units. And then if I had to change it to be millimeters squared, it would be obviously 1,000 millimeters times by 1,000 millimeters, which would give us 1,000,000 millimeters squared. So please be careful. If necessary, draw pictures for yourself and make sure that you actually have got the right units for square numbers. You could also do the same for 1 kilometer squared by drawing similar diagrams. And I've worked this one out for you to be 1 kilometer squared is 1,000,000 meters squared and 1,000,000,000 centimeters squared. Remember, it's got 12 zeros. Units of measurement can be converted from metric to imperial units and imperial to metric units. Remembering that metric units are our meters, centimeters, kilometers that we use in South Africa, and imperial units are our inches and miles and feet that they use in America and the UK. You do not need to learn these conversions. The conversions will always be given to you. Other definitions that you need to know are area. That's the amount of space that a surface or place or shape covers. And area is expressed in square units, which is what we were looking at just before. And an example of that is square meters. Perimeter is the total length of the sides of any shape. So it would be the distance around the outside. In circles, we would use the word circumference instead of the word perimeter, and that's the distance around the edge of your circle. These are the common formulas that you would be using to find the area and perimeter of squares, rectangles. I'm not going to go through these as they usually are given to you, and they are also on your X sheets. Triangles, parallelograms. Please note with a triangle and a parallelogram that you need to use the perpendicular heights. This symbol here is perpendicular, which means that it is at right angles, which is this symbol here, to the base. Similarly, with parallelograms also, you need to use a perpendicular height. It's the base times your perpendicular height. Remember, with perimeter, it's always the distance around any of those shapes. A trapezium is not so common, but it is one that you would be given the information for. Usually you would add the top and the bottom, which are your parallel sides of your shape, and you would then divide those by 2 and times by, again, your perpendicular height, which will be at right angles to your base. Looking at circles, we need to remember that the radius is half of the diameter. The diameter would be the whole distance from one side of the circle to the other through the center. And the radius is half of that, just going from the center of the circle to the edge. In order to find out the area, we need to use this pi times radius squared. Pi is a number, and sometimes they give us the number to use, 3,14. Otherwise, there is also the button on your calculator, which you need to use the shift and then pi. Let's try it again, shift, pi, and you'll see it comes up. If I push equals, you can see that it will be a long number, but often the exam papers will give you a definite number to use. The circumference or the perimeter of a circle is 2 times pi times your radius. Or you could also use the circumference as equal to pi times diameter. Part of this section is you need to also be able to use Pythagoras. Remember that Pythagoras is dealing with right-angled triangles only, which means that they have a right angle or a 90-degree angle within the triangle. Please note that the hypotenuse is the side that is opposite the right angle, and this is your longest side of a right angle triangle. The formula that you do need to know is that the hypotenuse squared is equal to the short side squared plus the other short side squared. So it's this side squared plus this side squared added together, and that would give you your hypotenuse squared. So in order to find out what your hypotenuse is, you would need to square root your answer. Remembering also that if you are looking for the short sides, you would need to then take your hypotenuse squared and subtract. So to find a short side, you would say your hypotenuse squared minus your other side that you have got already, take them away and square root it. So please note that if you are looking for a short side, there would be a minus in between, not a plus. Right, let's get on to some examples now so we can actually use this information. Right, example 1. This is looking at measurements and lengths and areas. Right, some of the first questions are just basic conversions, so I would have to convert from 2,3 meters to centimeters. I would need to remember some of my information that we've already looked at, that 1 meter is equal to 100 centimeters. Sometimes it's a good idea to actually write that next to what you're trying to do and say, well, if I was going from 1 meter to 100 centimeters, I've actually multiplied by 100. So I need to do the same with this example. And 2,3 times 100 is 230 centimeters. Let's look at the next example. This one, we're going from meters to kilometers, and we need to know that 1 kilometer is equal to 1,000 meters. We are going this way, we're going from meters to kilometers, so I need to divide by 1,000. So I'm going to divide by 1,000, which makes this answer 23450, which is 23,450 kilometers. Please note that if I'm converting from meters to kilometers, that my answer should be smaller. Let's have a look at example 3. Here you can see we are dealing with meters squared and centimeters squared. So therefore we need to remember our rules. We're going to be looking at 1 meter squared is equal to 10,000 centimeters squared. Remember, it is not 10 centimeters squared. So we need to times our answer by 10,000. So I'm going to take 2,3 and times it by 10,000 to get 23,000 centimeters squared. Right, let's look at example 4. This time we're going from centimeters squared to meters squared. So again, I'm going to write down the information that we know. So we know that 10,000 centimeters squared is equal to 1 meter squared, which means that I have divided my answer by 10,000. And I'm going to do exactly the same to this. I'm going to take my 22,300, should I say, and divide it by 10,000. And I'm going to get out my calculator just so that I don't make any silly mistakes. So it's going to be 2,300 divided by 10,000, which has got 4 zeros. And I get an answer of 23 over 100. So I'm going to push the S to D button to get 0,23. Okay, please remember, if in doubt, use your calculator. You will not be penalized for using your calculator, and it stops you from making silly mistakes. Let's look at example 5. 1 foot is equal to 30 centimeters. I measure the length of a desk to be 7 feet, 1 foot, 7 feet, and convert this to meters. In other words, I'm converting from imperial to metric. Again, I'm going to write down the information that I've been given. So 1 foot is equal to 30 centimeters. So 7 feet are going to be 7 times 30 centimeters. Let's get our calculator. 7 times 30 equals 210 centimeters. And I need to look back at my question and see it actually asks for my answer in meters. And I know that 1 meter is equal to 100 centimeters. So therefore, I need to divide my answer by 100 to get it to meters. So instead of writing 210 centimeters, it's going to be 2,10 meters, which could also be written as 2,1 meters. Please make sure that you look and see what unit of measurement they have asked your answer to be in, because that is a sure way to lose marks if you don't convert your answer. Right, let's have a look at this one. 1 meter is equal to 3,25 feet. I measure the length of a container. The length is 3,5 meters, and I need to send the measurements to an English company that uses imperial units. Convert the measurement from meters to feet. Okay, let's make a bit of space for ourselves. Again, I'm going to write down the information that I know. 1 meter is equal to 3,25 feet. And I've got 3,5 meters. So that's going to be 3,5 times 3,25 feet. Getting out my calculator again. It's going to be 3.5 times 3.25 equals 11,375. Feet. Looking back at my question, they want to convert from meters to feet. My answer is in feet, therefore I am correct. Right, now sometimes you can mix some of your questions with some of the number questions, and not always are, for example, ratios just in number. We can actually have ratios of measurements too. So this is a question that actually has a bit of number and space and shape. So question number 7 is write the ratio of 2,2 kilometers to 11 meters in its simplest form. Now remember, ratio, let's have a pen rather, is when I've got a number, for example 2,2 kilometers, with a colon to another value, and in this case it is 11 meters. Now before I can actually even simplify it, I need to make sure that they have got the same units. You can see that this one's kilometers and that one's meters, so you need to have the same units. And it doesn't really matter which way around you convert it. I always try and get rid of decimals, so I'm going to change this to be meters, so I'm going to times this by 1,000 to be 2,200 meters to 11 meters. Once my units are the same, I can almost cancel them out, and then I need to simplify. We know that 11 goes into 22, so I'm going to divide both sides by 11. 11 divided by 11 is 1, and I'm going to get out my calculator to do 2,200 divided by 11 is equal to 200. And that is my simplest form. I know that this is my simplest form because obviously my 1 cannot be simplified, so I know that that is my simplest form. The next examples we're going to be looking at are going to be on area and perimeter. Let's look at example number 8. You can see that this shape is made up of a rectangle and a triangle. It's a good idea to identify what type of triangle we've got, and we've got an isosceles triangle, which means that it has got 2 equal sides, and that's what those lines signify. So I can actually fill in this information that this is also 10 centimeters. This is a rectangle, so this side is equal to that side. So that's going to be 8 centimeters. So therefore we can find out very quickly what our perimeter is. I'm going to highlight where we actually are going to be measuring. We're going to be measuring along the outside here, up, across, and around. Please note that we do not find the middle line in the middle there. So our perimeter is going to be 12 plus 8. Can you see we're going along here? 12 plus 8 plus 10 plus the next 10 plus that 8 over there. And if we add those all together, that should get us 20, 30, 48. And because we've got a distance that we are measuring around the outside, that will just be in centimeters, not centimeters squared, just centimeters. So the perimeter of our shape is 48 centimeters. Now to find the total area of the shape, we need to look and see that the shape is made up of a rectangle and a triangle. So I can write my formula, total area is equal to the area of the rectangle plus the area of the triangle. Let's first look at the triangle. I'm going to draw a little arrow down this way. Right, we've got a triangle that looks like this. This is my perpendicular height. This is 10. We know that's also 10, but we don't really need that information. We can look and see that this is the same as that, so that's 12. And we need to find this perpendicular height over here. I'm just going to draw it as a separate rectangle, as triangle, should I say. And this is 10. This is half of this 12, so this is going to be 6, and I know that because this is an isosceles triangle and those two sides are equal. We're going to have to work out what this is, and we're going to be using Pythagoras to help us because it is a right angle triangle. Okay, so we know that our perpendicular height is going to be equal to my hypotenuse, which in this case is 10. Squared, remember, take away because we are finding a short side, and that's 6 squared, and we're going to square root it all to find out what my perpendicular height is. Let's get my calculator out. If I type that in, as you can see there, and I get an answer of 8. So now I can find out the area of my triangle, because an area of a triangle and usually they would give this to you on your exam paper, is half base times your perpendicular height. I know my base was 12, so it'd be half of 12 times by the 8. Using my calculator is going to be half times 12 times 8, which equals 48. So the area of my triangle is 48, and the area of my rectangle is going to be, let's have a quick look at what our shape looks like, 12 by 8. So it's going to be length times breadth. Length is 12, breadth is 8. 12 times 8 is 96. Now these are centimeters squared. And so I now can work out what my total area is going to be 48 plus 96. And so we don't make any mistakes, let's use our calculators to say 48 plus 96 equals 144. And remember, this answer is centimeters squared. Make sure it looks like a 2. And that is our final answer. Right, let's go on to a little bit more difficult question. This one is to find the shaded area of this shape. Give your answer to 1 decimal place. Again, at the end, you need to make sure that you have given it in the format that it actually has been asked for. Now, in order to work out this shaded area around the edge here, you need to actually have your big circle and you need to take away the little circle so that you can actually work out what that area is that is shaded. So I'm going to write my own little formula. So the shaded area is equal to the area of the big circle minus the area of the small circle. Right, it's not probably very clear, but the main big circle, the radius is 8,6 centimeters. And the radius of the small circle is 3,1 centimeters. So, what is the area of a circle? Again, this would probably be given to you. So, area is equal to pi r squared. And I'm going to use 3,14 as pi, so that I don't have so many decimal places, and that is actually what they've actually asked us to use. Again, use the information they have given you, because that's where you could lose marks if you just use your calculator button. Right. Okay, so my area of my big circle is going to be pi times the radius of my big circle, which is going to be 8,6 squared, minus the area of my small circle, which is going to be pi times 3,1 squared. And I can type this straight into my calculator as it looks right there and get an answer straight away. So, using the brackets, remember pi in this case is 3,14, so that's what I need to use. 3.14 times 8.6 squared, close my brackets, minus, open brackets, 3.14 times 3.1 squared, close brackets, equals, and my answer is 202,059. 202,059. That is my answer in centimeters squared. I need to go back and check. It asks for 1 decimal place. So I need to make sure that I've rounded this to 1 decimal place. So if I had to look at this, the number behind makes it go up to a 1. So my final answer should be 202,1 centimeters squared. And I'm going to underline that so that you can actually see that that is my final answer. Right, question number 10 is a bit more of a contextual type question. This is taken from a past exam paper, and this is the type of question that you're more likely to see. Example 10, Mr. Brown, the gardener at school, created a circular flower bed in a rectangular lawn as seen in the diagram. The radius of the flower bed is 1,5 meters, and the length of the rectangular lawn is 6 meters, and the breadth is 4 meters. And they've very kindly drawn pictures for you so that you can actually visualize what they are talking about. So you've got a rectangle and a circle in the middle of it. Right, the question actually is, calculate the following: the area of the flower bed. Remember, the area of the flower bed was the circular part, and the information that we need from the diagram is that your radius is equal to 1,5 meters. Okay, and it's substituting into this formula. They've told us to use this formula. My area is equal to pi times the radius squared. Pi is 3,14. Note that they've given you that value, and I need to times it by 1,5 squared. Getting out my calculator, 3.14 times 1.5 squared equals 7.065. And in this case it's measured in meters, so it's going to be meters squared. Right, so that is the actual area of the circular flower bed in the middle of the rectangular lawn, so it's the middle part. Now they want the perimeter of the lawn. Remember, the perimeter is the outside edge, so if, for example, they had to put a fence around the school or around the garden, they would actually then be using that measurement. So the perimeter of the lawn, and they've even given us the formula very nicely, so the perimeter is equal to 2 times the length, and in this case the length is 6, and the breadth, which in this case is 4. 2 times 6 plus 4 is 10. 2 times 10 is 20 meters. Please note, perimeter is just meters, not meters squared, because it is a distance. It is not an area. Right, now our favorite type of question. The length of the lawn in feet if 1 meter is equal to 3,25 feet. So I need to take that answer of 20 meters and I need to convert it to feet. Let me extend my page so I've got some space to work. Writing down the information I've been given first. 1 meter is equal to 3,25 feet. I want 20 meters. So that's going to be 20 lots of 3,25. And again, using my calculator, 20 times 3.25 equals 65 feet. Is that what they asked us for? Yes, they wanted the answer in feet. Right, the next example we're looking at is example number 11, and that is to find the area of the shape in meters squared. What shape is this? This is a parallelogram. And in order to find the area of a parallelogram, they would usually give this information to you. It's the base times your perpendicular height. And as you can see, we're very lucky in this situation because they've actually given us the perpendicular height and they've given us the base. So we should actually just times those two numbers together. The problem is is that they have got different units of measurement. Please note that in area and volume and perimeter, you cannot deal with different units of measurement. You need to make sure that they are uniform. So because they've asked us to have our answer in meters squared, the most sensible way of doing this is to actually change my units to be meters. So I know that 120 centimeters is equal to 1,2 meters, because 100 centimeters is equal to a meter, so therefore I need to divide by 100 to change from centimeters to meters. And so I now know that my base is 1,2 meters, and I'm going to times that by my perpendicular height, which is 2 meters. 2 times 1.2 is 2,4 meters squared. If I had done it the other way around, where I had converted my meters to be centimeters, I would then have to convert my meters squared and my centimeters squared between them. And that is often where we make our silly mistakes. So I would always change to be the unit that I want my answer to be in, so that it doesn't mean I have to have an extra conversion, which allows for silly mistakes. Let's have a look at example 12. Now this is a more difficult shape. As you can see, it's a shape that you don't often see, and this is your trapezium. And we need to read the information that they've given us. So it says, find the area of the shaded part if the radius of the circle is 15 centimeters. Now remember, the radius is from the center to the outside, and obviously that could be going downwards as well. And they told us that it is 15 centimeters. From this information, we can therefore find out that the height of my trapezium is obviously going to be 2 lots of radius, and that is obviously my diameter of my circle. And 2 lots of 15 is 30, so my diameter is actually 30 centimeters, and you can see that that also would be my perpendicular height for my trapezium. Okay, so now we've got some of the information that we need. We need to find out for the area of a trapezium. The formula is usually given to you as A plus B divided by 2 times your perpendicular height. The A and the B usually relates to the 2 sides that are opposite each other, perpendicularly away from each other, and sometimes you can call it the top and the bottom. So it would be 40 plus 20 divided by 2 times my perpendicular height, which I've just worked out to be 30. (40 plus 20 is 60 divided by 2 times 30. Running out of space here. 60 divided by 2 is 30 times 30 is equal to 900 centimeters squared. Again, if you're not sure, use your calculator. But is that what we were actually asked to find? We were asked to find the shaded part. So I didn't need to just find out what the trapezium area was. I needed to find out the trapezium area, take away the circle. So I need to now find out what is the area of my circle. Again, this formula would have been given to you, but you should actually know this one is equal to pi times your radius squared. 3,14 is what I'm going to use for pi, times my radius, and this is the part of the information that they have already given us, which is 15 centimeters. So it'd be equal to 15 squared. Using my calculator, 3.14 times 15 squared equals 706,5. And remember, this is centimeters squared. Right, now I need to write down what I'm actually trying to find out. I'm looking for the area of the shaded part. Now the area of the shaded part is going to be my trapezium, take away my circle. So it's always a good idea to actually write down what you are actually doing, because should you have made any careless mistakes throughout your sum, you will actually get method marks for showing the examiners that you actually do understand how to actually solve the problem. So area of the trapezium, I'm just going to write trap, minus the area of the circle. Okay, my area of my trapezium was 900 centimeters squared, and the area of my circle was 706,5 centimeters squared. Getting out my calculator again, I'm going to say 900 minus 706.5, which gives me an answer of 193,5 centimeters squared. And that is my final answer. I need to check back to see if they've asked for any specific formats. They haven't asked for any number of decimal places, and therefore I'm going to leave my answer as 1 decimal place. Should they ask for 1 decimal place, you need to make sure that your answer is in 1 decimal place, otherwise you will lose marks. Also, if they have not specified and you have got numerous decimal places, it's always a good idea to write down all of the decimal places and then round, because obviously they can then mark that you were correct if they didn't want you to round it. Right, let's go on to the next example. Right, look at the shape below. Find the length of one of the sides of the square, and then use this information to find the area of the whole shape, and then find the perimeter of the shape, not the dotted line. Right, so this is in 3 parts, so let's start at the beginning. Part A was to find the length of one of the sides of the square. Now, always have a look at your diagrams very carefully. You might notice that this doesn't look like a square, because with distortion of the paper or the printing, you might not necessarily have it the way it should look. So therefore, you need to look for the symbols. You can see that this has got 4 straight lines here, which means that those 4 sides are equal to each other, and therefore it is a square. Okay, to find the side of one of the squares, I need to have some other information. There's no information on my square, but they've told me that this side is 6 meters and that side is 8 meters, and therefore, and this is a right angle. So right angle should ring bells in your head. To find the third side of a right angle, what do I use? Yes, Pythagoras. Right. And do you notice that that third side is actually the side of the square as well? So we're actually going to be solving all of our problems at once. I'm going to draw this out so that I can see what I'm actually dealing with. It's not drawn to scale. So that's 6, this is 8, and this is the one I'm looking for. You can see that the side I'm looking for is opposite my right angle. So this is my hypotenuse, or my longest side. If I'm looking for my longest side with Pythagoras, the longest side is equal to the short side squared plus the other short side squared, and all of your answer is square rooted. Right, so my longest side or my hypotenuse is equal to 6 squared plus 8 squared, and my answer is square rooted. I'm going to use my calculator to find this answer. And so it's the square root, brackets, 6 squared plus 8 squared, close my brackets, equals 10. So my longer side is 10. So this side here is 10, and if I go up, you can label it on here, it's 10. And because this is a square, this is going to be 10, that's going to be 10, and that's also going to be 10. So we can see that we've got, let's write this a little bit clearer so you can actually see, 6, 8, and 10. Part A, the side of my square is equal to 10 centimeters. Right, B. Use the information to find the area of the whole shape. Now this is quite similar to the one we had previously. I've got the area of a square and I've got the area of a triangle, and in order to find my total area I need to add those two areas together. So total area is equal to the area of my square plus my area of my triangle. So the area of my square, we know that the side of a square is 10 centimeters, so that's going to be 10 times 10. And I need to add on the area of my triangle. The formula for triangles is half base times perpendicular height. And we need to be really careful with this one. Let's go back to our original diagram. You can see that this is my right angle here. So either this is my base and that's my perpendicular height, or this is my base and that's my perpendicular height. The new side that we've just found, the 10, does not actually come into the formula at all. So we need to go half 6, pen back, times my 8. It doesn't really matter which way around we write that, because 6 times 8 and 8 times 6 is actually the same answer. And to make sure we don't make any silly mistakes, let's go back to our calculator and type it in exactly as I've written it. Plus half times, sorry, need to get out of that, times 6 times 8. And we should put brackets in there, but because of BODMAS we can get away with not putting brackets in there. So my answer will be 124. 124 centimeters squared. Just check that your units are correct. We are working with centimeters, so therefore my answer should be in centimeters. That's the final answer for our area. Right, the last part was the perimeter. The perimeter of the shape is the distance around the outside. I'm going to draw it a bit neater at the bottom so I can actually see what I'm doing. So we had our square, which was 10 and 10 and 10. And then we had our two sides with a right angle in between. And this was 6 and that was 8. Remember, we don't have to include this dotty line. So my perimeter is equal to the 10 plus the 10 plus the 10 plus the 6 plus the 8. So that should give me an answer of 10 plus 10 plus 10 is 30, 36 plus 8 is 44 meters, centimeters should I say, because we're working in centimeters. Right, going back, let's check that we've actually answered all of our questions. We found the side of the square, so we've done that. We found the area of the whole shape, and we found the perimeter. Right, we've shown all our working out so that we can get our method marks, and we can now go on to the next question. Right, we're going to go back and do a few more examples on measurement and make sure that we actually have got that working correctly for us. So let's have a look at the first question of example 14. It says, write the ratio of 2 kilometers to 1,500 meters in simplified form. Okay, remember that means in the lowest possible units. So first of all, remember what we did before was we converted them to be the same units. And again, I'm going to choose to change my kilometers to meters. So I'm going to write this as 2,000 meters to 1,500 meters. Remembering that 1 kilometer is equal to 1,000 meters. And that should be information that you should know. Once I've got the same units, it's almost like we can cancel those out and we just need to deal with our numbers. You can see because they've both got 2 zeros that I can divide by 100 and I'll be left with 20 to 15. And what number goes into both 20 and 15 is 5. So I'm going to divide both sides by 5 and I'm going to get an answer of 4 to 3. And that is my simplified form. It cannot be simplified any further. There's no number that goes into 4 and 3. Right, the next question, we need to change from meters to centimeters. I always like to write down the information that I know. 1 meter is equal to 100 centimeters. And therefore, if I'm going from meters to centimeters, I'm timesing by 100. So I need to take my answer and I need to times it by 100. And 2,56 times by 100 will give me an answer of 256. So 2,56 meters is equal to 256 centimeters. Please note that you can see that this is getting bigger. So therefore you're going from meters to centimeters, your number should get bigger, and 256 is bigger than 2,56. The next example, we're now converting from meters to kilometers. Let me write down the information that I know. That's 1,000 meters is equal to 1 kilometer. So I'm actually dividing by 1,000. So I need to take this and I'm going to divide by 1,000. Let's use our calculator so we don't make any careless mistakes with decimal places. So it was 2230 divided by 1,000 is equal to 2,23. Please note that if I had to divide by 1,000, I could put a 0 at the end there, but it's not necessary. Right, the next one is where we really need to be careful. Remember, when I've got meters or centimeters or millimeters squared, I need to make sure that I've actually used the correct information. If in doubt, always draw little pictures for yourself. 1 centimeter squared was 1 centimeter by 1 centimeter, which is equal to 10 millimeters by 10 millimeters, which is 100 millimeters squared. So to go from millimeter squared to centimeter squared, I need to actually divide by 100. So I'm going to divide by 100, and my answer should be 1230, which is 1,230. Right, part 5 of this, you need to convert 2.3 inches to centimeters if 1 inch is 2,5 centimeters. Okay, so let's write down the information that they've given us. 1 inch is equal to 2,5 centimeters. And so if I've got 2,3 inches, I need to say 2,3 times 2,5 because I've got 2,5 lots of 2,3. And if we do that on my calculator, it's going to be 2.3 times 2.5, giving an answer of 5,75. What units have I changed this to? I've changed it to be centimeters. Make sure that you have put in your units, otherwise you could lose some marks. Right, we've got to the end of this section on area and perimeter, and you need to remember that you need to always show all of your thinking. Draw pictures, put every bit of information that you can onto the page so that the examiner can see what you are thinking. If you show them that you actually understand how to solve the problem, even if your numbers are incorrect, at some point you've made a silly mistake, you will get method marks and follow through marks. So remember to make sure that the examiner knows exactly what you thought and exactly how you were going to solve that problem. Please remember also to watch the next 2 parts of this space and shape so that you can actually see some of the harder examples and how we need to go about solving problems. These were quite basic questions in this section, and they were just focusing on the area and the perimeter. Good luck and see you next time.